everyone! Welcome to Pandas for Productivity, the show where I bring a business person's perspective to data analysis. Moving averages are a very common thing that you look at with business performance. It takes away the noise from daily pops and drops and gives you an idea of what your current run rate is. At the same time, it's really troublesome to be calculating these in Excel. So, the whole idea of Pandas for Productivity is to look at Python workarounds that will reduce the amount of time you spend in Excel from hours into minutes. When I was looking for a time-saving alternative to calculating moving averages in Excel, the first place I looked to was SQL and its Windows functions. And those are great. However, they are not the only option that's available. You can also do rolling averages in Pandas. Just use rolling, which you can then append a method such as a sum or a mean, and that's probably all that you will usually use in business, and you'll be able to calculate rolling metrics and add them as a new column to your data frame. This is a query that shows the daily new confirmed cases of COVID-19 in the US. Let's say we want to get the rolling average of new cases for every 7 days. We can use rolling. Just put 7 as its argument to size the window of 7, and then you chain the method mean to get the mean across that window. This is going to create a new column in the data frame, as you can see here. First of all, you're going to see that the first 7 rows of this data frame has blank values, also known as not a number. This is because unlike the SQL window functions, Python is smart enough to know that you get confused if you have a rolling average that is less than 7 days. So it's going to wait till you have 7 full days of data before it gives you a rolling average. To validate that the rolling average function actually works, I'm going to export the data to a CSV file and look at it in Excel. So here you can see this is a code cell that exports the data frame into a CSV, and it appears here in my output folder in Kaggle, where I can then export this CSV file. Okay, now we have the data in Excel. I'm going to just quickly type in a manual formula and we can check that the numbers match. So you can confirm that this is what the rolling is doing. It's giving you a rolling average for all the data rows that have more than 7 days of daily data preceding to calculate a full 7-day rolling average. And for those days that do not have 7 days, they will not have any data. So in a nutshell, that was how you use rolling with an integer window. There are 3 things that you need to note in order for this to work. Number 1, you need to have all your dates during your time period, so you cannot have any of the dates missing. Number 2, you need all your dates to be organized in consecutive order. This is because it is going to take that window on rows, so you want to make sure that your preceding 7 rows are going to indeed be your preceding 7 dates. And number 3, you need to have all your dates having a valid value for that metric that you are calculating the rolling average on. So if we had a null or a blank, meaning missing data, on any of those new confirmed case values, then rolling is going to stop calculating and it will only start again when it has 7 days of preceding dates with valid values. Now that we have looked at a basic way that we can use the rolling method, I'm going to touch on 3 other areas that are a bit more advanced but still useful. Firstly, I'm going to compare what happens when we use a date offset versus an integer for the window. Secondly, I'm going to look at the min periods keyword argument And thirdly, I'll look at the closed keyword argument. There are a few other keyword arguments that you can use, but these are the key ones. For these examples, I'm going to use a slightly more difficult data source. I'm using Hong Kong's data because, as you can see, we have some days that have 0 cases, and sometimes this is going to represent itself as missing values. So, firstly, I'm going to use the integer window. So, integer window means that you just put an integer within the brackets for rolling, and what that does is it counts rows. So that means it's going to count the previous 7 rows up till the current row. It's going to start from the first row that there are 7 rows preceding it. That means it's the 7th row. So in this case, that would be row number 6 in the entire data frame, and the 7 preceding rows would be rows 0 through 6, so including itself. So let's see how that works. As you can see here, it starts from row 6, which is the 7th row since we started counting at 0. And then once you see that there is a blank value, it's going to not know what to do. So it's going to carry on until there are 7 preceding non-null values, and then it's going to pick up again. So the purpose of the offset window is that, unlike the integer window, it recognizes that we are counting on dates and not on rows. To make this work, what we need to do is to set the index of the data frame to the date column. So the index means that it is this column here that is in bold, and what it does is that it will show a value that is used to look up any particular row in the data. So right now the index has just been the row number because we did not set it to anything else. If we set it to the date, you're going to see what happens. So it's going to show the dates here as the index, and you do not have a date column anymore because the date column has become the index. So this is the syntax here. You can see that there is the capital D, and 7D is represented as a string. So this is a 7-day date offset. And what it means is that with the index being a date, Pandas is going to know how to calculate the rolling mean based on the last 7 days before that date. So I'm going to run this, and this data frame, because it's adding on new columns to the original data frame, is going to show the 2 ways of calculation side by side. So you can see where the difference comes in. For the date offset, it starts calculating right from the first day, although the first few days are not going to be so accurate because it's not going to have 7 days worth of data. So it's just going to calculate the rolling mean on whatever dates that there are available. So this is averaging just 12, and then 12 and 0 average is 6, so on and so forth. So it really starts to converge with the 7-day mean only from the 7th row onwards, and you can see that these values are equal. The difference is that the date offset is going to know what to do when we encounter a null value during one of the days. It's going to calculate the rolling average over the past 7 days regardless, treating that null value or missing value as though it was 0. So you can see that for these 7 days, from the 23rd until the 29th, it was able to calculate the rolling averages, whereas the integer window was not able to do so. Now let's talk about the min periods argument. So what this does is that it sets the minimum number of periods before this particular row that need to have valid data before you would calculate the rolling average. If I put mean periods equals to 7 within this rolling 7 days date offset, what I'm going to get is this. I'm going to get exactly the same output as the integer window, because the integer window was calculating only the rolling averages for which there was 7 days of valid data prior to the current row, and that is exactly what the min offset 7 days is also doing. First of all, we are going to fix the issue of the nulls so that we can compare our data more accurately. This is how I've done it. I've just used fillNar to fill 0 in the value that is a null. Then what I do is that I want to compare what close equals to left is going to give me in terms of the averages. So I add close equals to left, and I'm going to create a new column in this data frame. So let's run this, and then we can see what is happening here. So close equals to left means that it's going to take all the values, not including the current value. So you can see that it's one row off from when we had close equals to right. In other words, it's going to take the average of these 7, not including the current row. I'm going to quickly go through what happens with the 3 types of windows in Excel. So for the right window, what's happening is that you're including the current row. So that means that you are going to take these 7 values for your rolling 7 days that ended on the 21st of October, and we can check that this is correct. So you see this value matches with what we are getting here with the right window. Now with close equals to left, what we are going to do is we are going to take the 7 days before the current date. So that means we are not going to get any dates before the 22nd of October, because we are not including the current row when we are counting 7 dates. So you have left window average of these 7. So that is why you're going to get the same value as the right window, except that it is going to be 1 day later. Now we are going to review the calculation for both window. It's going to be the combination of both left and right window. So right window is going to give us these 7 days combined. So I'm going to shade this off in yellow. And then the left window is going to give us these 7 days, which I will shade off in green. So let's confirm. I'm going to take the average of everything in this shaded area. So that's not going to be 7 days but 8 days. And that's where I'm going to get this value, 8.375. This completes the overview of the rolling method that I wanted to give you today. I'm really excited because I think this has the potential to increase my throughput, and also because there hasn't been much documentation about this method on the web or in the Pandas 1.x cookbook. So I had to do a lot of my own trial and error in order to bring this episode to you. I hope that you found this useful, and thank you.